So let's start building our first Houdini project. And what we're building today is this squishy Vellum animation that you saw in the beginning. So I've opened up a new and empty scene in Houdini, and I first of all want to do a little bit of prep work. The first thing that I want to do is that I want to save my scene inside its own little project folder. So for this, let's go to File and Save As. And in here I have my general project folder for this video. And I'm going to create a new folder, call this Houdini, hit accept, and then let's also give it a name, something like this. The reason I'm creating a project folder from the very beginning is because this will make it a lot easier later to create relative references to different data or different files that we might want to link in. And this, of course, makes it much easier to pack the entire Houdini project and give it, for example, to another artist to keep working on it. It's just a very good habit to get into when building Houdini scenes. Also, I want to rearrange my view in here. You may want to do this as well, but you don't have to. In my case, I'm going to drag this window over right here, so we get a lot more room on these two panes. I'm also going to close the upper pane, the parameters, by clicking on this small triangle and saying close pane all tabs. And again, I'm going to bring in my parameters by, with my mouse in the node editor, hitting P for parameters, and here are my parameters again. If you did the same thing and you want to go back, you can of course go to build and reload current desktop to reset all these changes. But for now, let's start building our squishy Vellum. And first of all, I want to drop down an empty geo container to build my setup in. This is the same as dropping down the box or the rubber toy node from the very first video. In this case, we're dropping just an empty object down into our scene. So for this, let's hit tab and let's search for geo or geometry, and let's drop down a geometry node. And my parameter pane is quite huge, so let's make this smaller. And here we have our geometry container. And maybe make a bit more room here. Let's jump into this container. This is where we'll do most, if not all, of our work. And now let's start building some of those squishy objects that we want to have in our simulation. And first of all, I want to start with a sort of chocolate bar looking shape. For this chocolate bar, I first of all want to drop down a primitive object as a base, and in my case this will be a grid, something like this. Now I want to change the size of this grid. By default in Houdini all those units are in meters, but for our scene right here we don't really care too much about it. We really only care about the size of the different objects in relation to each other. And in general you can work with exact measurements in Houdini, but you don't have to. In my case, let's change the size to a value of 0.7 and 1.4 to make this a lot more chocolate bar shaped. And let's also adjust the rows and columns, in my case to 11 rows and 6 columns to get roughly square divisions. Now to turn this flat grid into a chocolate bar, I first of all want to extrude it up. So let's search for extrude. And Houdini comes with 3 different extrude nodes. In pretty much all cases, you probably want to use the poly extrude node. So let's drop this down, wire this in, and increase the distance slider to give our chocolate bar some thickness. For this scene, I chose a value of 0.05. Now, one thing to look out for with this poly extrude node is if we take a look at the bottom of a chocolate bar, we can see that this is open. We're seeing this dark blue-gray, which means we're looking at the backside of polygons, and we can fix this by setting a check mark here at output back. So this is the base of a chocolate bar. Let's now create those little hills or little divisions that are typical for a chocolate bar. And for this, again, I want to use a poly extrude node. So search for this again, wire this down. And in here, I first of all want to set the mode or the divide into mode, not to connected components, but to individual elements. So this way we'll be extruding every face individually. And I can extrude all faces up and give them a little bit of an inset. Now, of course, I don't want to do this for my entire chocolate bar, but only the top surface. So to select the top surface, or to limit the effect of this node to the top surface, I can make use of the group field again, and again click on this arrow icon up here, and I can look at it from the top have to make sure that I select this button right here to select visible geometry only, and then I can draw a simple box selection on the top of my geometry. And again, this is only affecting the top. Now with my cursor inside the viewport, I can hit enter to accept my group selection. And now we're only extruding the top faces of our chocolate bar. Let's enter the right values. Again, I want a distance of 0.5 and an insert of 0.25, something like this. Next, I want to bevel my chocolate bar, so let's drop down a poly bevel. And in here, I want a distance of 0.012 and I want 2 divisions, something like this. And finally, to finish my chocolate bar, I want to smooth the entire geometry a bit. So let's drop down a smooth node. And that's maybe a bit much. Let's smooth it a value of 3.2, something like this. And also, if I take a look around my chocolate bar, I can see a few sharp edges, which I don't want. So let's also fix our normals by dropping down a normal node and set the cusp angle to 180 degrees to make the entire object smooth. And this is our first object done. So let's maybe also hit A on a keyboard to get into arrange mode, and then simply starting out from a grid, drag down to arrange all the nodes into a nice column. Let's create our next object, and our next object should be a sort of gummy worm-like thing. For this, I want to start out with a circle, and we got different presets for a circle. If I just search for circle, and in this case I want to use the create preset. This leaves me with something like this. I want to make the circle a bit smaller. I want to set the uniform scale to a value of 0.5. I also want to up the divisions to 50. And I also want an open arc, not a closed arc. So in this case, going from a value of 50 degrees to a value of 310 degrees, something like this, to get a sort of C shape. Now we have a polygon curve, and to turn this into a gummy worm, I want to use first of all a sweep node. Right now the sweep node is complaining because it expects another input on the second input, but I can fix this by setting the surface shape from second input cross section to a ribbon, and now this is starting to look more like a gummy worm. I want to set the columns to a value of 10, so the divisions are along this axis. I want to set the width to a value of 0.4 to make it a lot wider. And if I scroll down a bit, I want to roll my gummy worm, in my case a value of 90 degrees to make it nice and flat. Now this is still no volume, so to give it volume, let's use a poly extrude. And here I want to set a distance of 0.05. Again, I want to output the back, and also I want to create some divisions along this extrusion axis, and I want, in this case, 4 divisions. And as before, this has a lot of sharp edges, which I don't want, so again, let's smooth it by using a smooth node. In this case, I want to increase the strength to a value of 15, and again, I want to smooth all my normals by drawing down a normal node, and again, setting the cusp angle to 180 degrees. This is our second object done. Now for a third object, I want to create a sort of jelly-like shape, and I also want to use, instead of the poly modeling tools that we took a glance at here, I want to use the volume modeling tools that Houdini comes with. For this, again, I want to use a base object, or in this case 2 base objects. I want to use first of all a box. Let's drop this down. Again, I want to make the box a bit smaller, a uniform scale of 0.5. And I also want to bring in a sphere, again using the sphere create preset. On my sphere I want to change the uniform scale as well, in this case to a value of 0.6. And I want to move my sphere to one corner of my box. So for this, let's first of all ghost our box, so we can see where we're putting our sphere. And in this case I want to set the center to a value of 0.25, 0.25 and 0.25 to essentially move it to one corner of our box. And finally, this is divided a bit coarsely, and I want to make this a bit finer by increasing the rows to a value of 32 and the columns to a value of 64. Now to get into volume modeling, I want to turn both of these spheres into volumes. Now volumes themselves will get their own little topic inside this whole course. In this case, I want to just keep it short and simple. And I want to convert both of these objects into VDBs. VDBs are one type of volume that Houdini comes with. So for this, let's search for VDB. And in our case, to turn those into VDBs, I just want to search for VDB from polygons like this. Drop this down. And if I wire my box into this node and set my display flag here, I can see that the appearance of my box has changed and now looks a bit voxel-like. Now the number of voxels are a bit coarse, and I can change this by adjusting the voxel size, and in my case I want a voxel size of 0.02. Let's do the same for our sphere. I can just copy the node by hitting Alt on my keyboard and dragging. So now I get an exact copy of the node I started out with, and I can wire in my sphere to create a volume sphere. Let's combine both of those into a single geostream, and I can do this, for example, with a Boolean union. And in this case, it's a VDB union. So let's search for VDB union, VDB SDF union, and drop this down. And now both geostreams are combined if we wire in both nodes into both inputs. Now again, I want to get rid of sharp edges. So again, I want to smooth my geometry, and in this case, I want to smooth a VDB. So let's search for VDB smooth, and I get two options here, VDB smooth and VDB smooth SDF. The difference between them is something that we'll get into later in this course. For now, you can just keep in mind that if you use the VDB from polygons node to turn geometry into a VDB, you have to use the VDB smooth SDF node. Let's drop this down. Let's wire this in. And of course, our geometry gets a lot smoother, and I can control the amount of smoothness with those sliders in here. But in this case, I want to stick to the default values of 4 iterations. Now finally, I want to turn my VDB back into polygons. And unfortunately, there's no VDB to polygons, but there is a convert VDB node which we can use to convert our VDB into other geometry formats, in our case polygons. So let's wire this in, and let's set convert to polygons. And the mesh that we're getting here is a bit wonky and not really that great for simulating, so I want to also remesh my geometry to get a more simulation-friendly mesh. And for this, I can use a remesh node. Let's wire this in. This is a bit coarse, so I'm going to go to the target size and set this to 0.075. And I'm also going to the iterations up here and increasing them to just make the mesh a bit neater. And again, as always, I got some sharp edges in here, so let's fix those again with a normal node and setting the cusp angle to 180 degrees. So these are my 3 squishy objects, and before simulating them, I maybe want to save them out to disk. Now, we're in Houdini, and a lot of things in Houdini go via nodes, and also saving geometry out is done via nodes. So for this, let's drop down a node called ROP geometry output. Now, whenever you're saving out something in Houdini, this ROP, which stands for rendering operator, is something that you might want to search for. Also in Houdini, pretty much saving anything out, not just rendered frames, is called rendering. So this is a render operator that saves out geometry. To use this node, let's wire it into our grid, and let's take a look at the parameters. We can ignore a lot of this. Up here we have a save to disk button, which is pretty self-explanatory. Right here we can decide if we just want to write out a single frame or frame range. And here we have the output path, and the output path looks very, very strange because we have a lot of these dollar variables in here. Now, you can just enter a normal file path by clicking on this button right here and getting to a file browser right here. But I want to encourage you to work with those dollar variables because they can be very handy. What's set up here is with this first $hip is we're saying that we want to save our geometry in the same folder as our hip file. And this is why we created a project folder earlier. Then inside this folder, we want to create a new folder called geo. And then we want to write a file in here with this file name. And what is this file name? We're starting out with $hip name. And this is the same as our Houdini file up here. Then it's $OS, and that's the name of this node right here. So for example, I can name this node squishy_01, and this will show up in the file name. And then we're adding the current frame number. And since we're saving out just a single geometry and not a frame range, we can get rid of this. And then we have the file type, and the file type is bgeo.sc. Bgeo is the Houdini internal file type, and if you're just saving out geometry to load them in to another Houdini scene or in the same Houdini scene, I want to encourage you to use bgeo, because bgeo is just a very, very flexible file format that doesn't come with a lot of limitation, like for example obj and so on. Of course, if you want to move geometry to, for example, Blender and so on, you have to use obj or something else in here. And then with this $sc in here, we want to tell Houdini also to compress this file type to make it a bit smaller on disk. In this case, we don't need it, so let's get rid of it and just leave it at bgeo. And again, this might seem very complicated, but this can be a very handy thing, because with a setup like this and this variable-based file name, now I can just copy my rough geometry output and the name automatically changes, and therefore also my file name will automatically update, and I don't have to adjust every single file name in here for every output that I'm going to create. And also, since we have this $hip name in here, I can also very quickly see where each file is coming from, which is this Houdini file in here, which is great for readability of the final setup. And also, since we're saving inside the same folder as our hip file, our paths will already be all relative, so I can easily package my entire project folder up and give it to another person, and they can continue working without relinking anything. But now with this done, I can go through each and every node and hit save to disk, like this. And if I move into my project folder, I should see here that I have a geo folder right here. And if I jump inside, I have these 3 files that I saved out. Now, if you're following this tutorial series with an apprentice version of Houdini, these nodes won't work, because of course Houdini doesn't want you to save out huge parts of geometry to render them in another piece of software. However, for a simple setup like this, you can still save out your geometry. In this case, you just have to set your display flag at the last node in one of those trees, right click it, and go to Save and Geometry. And now you can set your file path inside the file folder right here. Don't forget to add a file ending to your file name, and then in the end hit Accept, and this will also save out your specific file. This is it for the first part of the setup, and in the next part we will take a look at how to sim all our objects and also how to export the simulation, for example, into Blender.